So let's do an example of a one-tailed test. And let's use the example that we've been using so far. But let's say that instead of the question reading was there a difference between the education majors and the rest of the students, let's ask the question, if the education majors GPAs are greater than everyone else's, than all the students. All right? So we know instantly that this is a one-tailed test because of greater. And we know if it's a one-tailed test, it means that it's on the positive side of the number line, right? So everything is the same. We follow the same steps. We'll use a z-obtain formula that we've been using for a one-sample test, which is z obtained is equal to the sample mean minus the population mean divided by standard deviation, n minus 1, right? Everything remains the same, and we got 4.62, right? Nothing changes there, right? But what does change is our normal curve, right? So in our normal curve, in our rejection region, it was a two-tailed test before, and the two-tailed test meant that we were on both tails, right? But now our rejection region is not on both tails. Our rejection region is simply on the positive side because it's a one-tailed test. When it asks greater than, it's just over here, right? So our z obtained was 4.62. It still is in the rejection region. So we will reject the null hypothesis, and in this statement we would say that there is a statistically significant evidence that the education majors GPAs are higher than the rest of the students. And the actual hypothesis test looks like this. So again, it's just the alternative is just the opposite, that it is not. Okay.